Hi, welcome to our pre-calculus. The topic today is finding solutions in an interval for a basic trigonometric equation involving sine or cosine. So here's an example. We want to solve 4 cosine of theta minus 2 radical 2 equal to 0. And we want to find all solutions that are in the interval from 0 to 2 pi. 0 is included, 2 pi is not included. Sorry, this screen is very sensitive. Okay, so this is very similar to the equations that we saw in the review section. In the review section, you can go and I review just basic aspects of solving equations themselves and just be ready with the terminology from there. So if I were to ask you to solve 4 cosine of 4x minus 2 radical 2 equal to 0, what would you do? Well, in the reviews we said we would take the number to the other side, 2 radical 2, and then x is 2 radical 2 over 4. So x is equal to radical 2 over 2. But of course the equation is not given in that style to us. What is given is 4 cosine of theta. So what is happening here is that instead of our trusty x's all around, we have sine or cosine of it all around. So this is what I replaced with x, and then I solved it. So what I really have is that cosine of theta is radical 2 over 2. So what we did here is called substitution. Sometimes to remove the clutter from a situation, you make a substitution, and that makes things to come into focus. So cosine of theta is replaced by x. We go ahead and solve the equation. Now x is radical 2 over 2. So here's my x. But x wasn't the subject that we wanted or we were after. It was cosine of theta. So cosine of theta is radical 2 over 2. Now the question is, what angle is it whose cosine is radical 2 over 2? How do we answer that question? Essentially, at this level, from memory, we have seen this angle before. We know the angle in the first quadrant would be the 45 degrees or pi over 4. So theta, if it was in the first quadrant, it would have been pi over 4, 45 degrees. It's saying find all solutions, and that's a critical thing here, from 0 to 2 pi, not necessarily just in the first quadrant. So this is going to bring us to several topics. One way of looking at this is through the issue of the unit circle you have played with in this course. So you remember this is cosine of the angle, and this one is the sine of the angle. So which one of them is radical 2 over 2? Well, it's just obviously labeled for us here is pi over 4. But as we go around the circle, when we come back into the fourth quadrant, there's another angle, 7 pi over 4 or minus pi over 4. So the 7 pi over 4 goes all around and comes back here. That one also has a cosine which is radical 2 over 2. These two share the same cosine. This location here is radical 2 over 2. This is the x, radical 2 over 2. And both of these are going to be acceptable answers. Now, why not say minus pi over 4? Only because we are limited to this range of numbers from 0 to pi over 4. So the second answer here is 7 pi over 4. And when you enter the items on LX, you separate them by comma to make them stand apart. Okay, that was one way of answering the question. Another way is to go ahead and draw the graph of cosine. So let's go ahead and draw. So this is, say, the angle theta, and then here is cosine of theta. What did cosine look like? Suppose this is 1, and this is pi over 2, and therefore this is going to be pi, and this is 3 pi over 2, and then say 2 pi. So our graph would look like something like this. Well, perhaps my 2 pi has to be here. This is theta. Let me clean it up a bit. Okay, so this is a graph of cosine of theta. Theta is on our horizontal axis, cosine is vertical. We did this kind of graphing a while back. What is it that we want the cosine to be? We want it to be radical 2 over 2. So this is, say, radical 2 over 2 is almost 0.7, radical 2.2. So we do something reasonable here. I want my vertical to be radical 2 over 2. So I go ahead and draw that line. Wherever I see the intersection, that's the angle I'm after. So this is the first intersection, pi over 4. At pi over 4, cosine matches to radical 2 over 2. Here's another intersection. This is where 7 pi over 4 is sitting. So two answers in the interval from 0 to 2 pi. Now, if you care to go further, well, there's going to be other answers here. So, for example, this one is also here. It's 9 pi over 4. But the problem in this section is just asking us to stop at 2 pi, not to go any further. So, finding a solution in an interval, interval is referring to this. Just keep yourself limited to that range of numbers. Other than that, everything's fine. So it's important to understand the basic ideas here. Solving it by memorization is going to be straightforward. Understanding what is involved is a bit more substantial. In this section, you're being asked to do everything in terms of radians, so that's what we did. Next, the rest of these problems are very similar to what we have done here. So again, think about this as your x. So focus on that. Sine of theta, we are taking 4 radical 3 to the other side, 4 radical 3, and then we divide this thing by 8, just like what you would do with an equation. So you get minus radical 3 over 2. So minus radical 3 over 2. The question now is, what is theta? And we want to keep ourselves in that range of numbers and give answers in terms of radians. So several answers, several style of arriving at the answer. You can do from memory. You can use your unit circle picture, or draw the graph of the sine and come up with the answer in either of these styles. So why don't you pause this thing, try to find the answer by yourself, and then come back. Okay, so here let's go back here. Minus radical 3 over 2. First of all, where would we go look for it? This is supposed to be sine. So sine is the second entry here. Let me clean this up so that so don't pay attention to that bold green. We are recycling the picture that we had. So sine would be, we have to look for it in quadrant, since it's negative, we have to look for it in quadrant 3 or 4, minus radical 3 over 2. So this is minus radical 3 over 2, and here is it showing up again. Now, what does horizontal stand for? Horizontal stands for function cosine. Vertical stands for function sine. So when we say radical minus radical 3 over 2, that's the value of y. Y is what we are caring for. The y of these 2 points, either of these 2 points, the y of either of these 2 points is minus radical 3 over 2. So if you wanted to answer this, you would come to minus radical 3 over 2. So from origin you come on the y-axis, minus radical 2 over 2, go horizontally until you hit the unit circle. These 2 locations are the angles you are after. So one answer is this, and the other answer is this one. These are your 2 answers. Now, here you're being aided by the fact that it's already labeled for you. This is 4 pi third, this is 5 pi third. But what if you had to do this thing by yourself? You go to, say, calculus class, they are not going to be handing this thing to you. So radical 3 over 2, you remember that matches with 60 degrees or pi third. So this is pi third. This is pi third, and then of course this is pi, and then you add them and you get 4 pi third. So that is where this angle comes from. How about this 5 pi third? Well, this is again that 60 degrees. You're taking off from 2 pi minus pi third. Again, you take a common denominator, 6 pi minus pi, and that is 5 pi third. So that becomes your second answer. So theta becomes 4 pi third, or 5. What did we have here? 5 pi third, 4 pi third, and 5 pi third are the 2 answers in this case. How about this one? Well, in this case, sine of theta. Take this thing to the right hand side, divide by 2. So sine of theta is radical 3 over 2. We realize 2 things. One is that this is positive, so the theta I'm looking for is either in quadrant 1 or 2. So that's where I will look. How do I look for it? I draw my circle. So suppose we are on a deserted island and all we have is sand in front of us, and the only question facing our life is what's the angle whose sine is radical 3 over 2. Wouldn't you think about that if you were on a deserted island? So on that sand, we take a piece of rope or something and draw a circle of what we assume to be radius 1. Next, radical 3 over 2. So, hopefully you remember how to approximate radical 3. 1.7 over 2 is almost 8.785 or something like that. 8.7. So the best you can, draw radical 3 over 2. Whatever approximation can come up with, radical 3 over 2. Next, draw a horizontal line from there. Then connect it to the origin. These are the 2 angles you're after. Of course, in this case, you are blessed by the fact that this is a famous angle. You already know what the angle is. One angle is pi over 3, and the other angle is 2 pi over 3. That is when life is smiling at us and everything is nice and proper, and we can find the answers easily. But in case we wanted to get a little bit of help, let me again go ahead and clean this thing so that you are not distracted by the old answers. So So of course, again, this was cosine, radical 3 over 2. Here's my radical 3 over 2. Here's a radical 3 over 2. You remember sine is matching with the y. These two answers come about if you go to radical 3 over 2 and go right or left. Once you hit the circle, you have your angle. What are the angles from here to here? And the other one is from here to here. And these are just as labeled for you to pi third and pi third, and therefore you are home free. Now you have your angles. So that was one style. Here we said we want to get used to the idea of solving by let me so sine of theta, well, this was a bit too well. So I make my 5 points, and sine of theta perhaps comes to its maximum here, and comes to its minimum here, and then back to 0. Radical 3 over 2 is, say, somewhere here, radical 3 over 2. So this is 1, the maximum, and this is radical 3 over 2. We draw a line, see where we hit. This is the first intersection, and this is the second intersection. My graph is not too good scale, so the answers as we see it, it's not is not accurate enough. So this is where the pi third is, and this is where the 2 pi third is. So that's how to get the answer by drawing a picture. But right now, again, radical 3 over 2 is one of the famous angles. We go to the unit circle, we find the two answers that match our case. How about this one? Well, this one turns out to be cosine of theta is equal to 0. So perhaps you can say, at what angles does cosine become 0? Well, theta is, we know at pi over 2 it's 0, at 3 pi over 2 it is 0. Let's go ahead and check again from so cosine is supposed to be 0 here. When is it 0? Cosine is x. Cosine matches to x, sine matches to y. So cosine being 0, that's the angle. That's the angle at which your cosine becomes 0. Here's another 0. This is the angle at which your cosine becomes 0. So yeah, we have the two answers here, cosine. And again, if you wanted to see it on the graph of cosine, you say, okay, here is, say, 1 pi over 2 pi, 3 of pi over 2, and then 2 pi. So now we want cosine to be 0, so we go to 0. This is where 0 is. Let me use another color. So 0, where does line 0 hit my graph? So here is one location, pi over 2. Here's the other location, 3 pi over 2, and now I am done. Well, how about this one? Sine theta equal to 0. Sine theta equal to 0. Theta has to be either 0 or pi. Is that right? So we go back to this picture again. If you want sine to be 0, sine to be 0, that sine being 0, at the angle 0 or angle. So right here is one answer. The second answer is going to pi. Again, remember, we are limiting ourselves in all of these problems to the first circle from 0 to 2 pi, and 2 pi itself is excluded. Okay, just so that it is left for the next cycle. So if you want to say, well, I can come back, yes, I can come back here and my sine will be again 0, yes, and that angle will be 2 pi, that's fine. It's just that that angle is left for the next batch or the next cycle. So that is not part of our answer. So that is not listed in the answers here because simply for this technicality that the problem says short of 2 pi stop. Okay, for whatever reason it says let's sort of 2 pi stop, and that's what we are doing. Okay, here cosine of theta becomes 1. At what angle does cosine become 1? So theta is equal to 0. How about another one? All of our questions had two answers. How come there is just one here? Well, the next one at 2 pi is excluded, and we are right at the very edge of the picture. So let me again to go ahead and remove the previous answer. We want cosine to be 0. Want cosine to be 0. Here's cosine is 0. Excuse me. We want cosine to be 1. We want cosine to be 1 is x. It happens at angle 0. So cosine of theta equal to 1. Angle is 0. How about the second solution? This is, we always drew a line here. For example, we drew a line and say, okay, one answer and the second answer. Oh, again, this is strange. Okay. The palm rejection of the screen is not that good. So this would have been answer 1, answer 2. But if you draw this line closer and closer to the edge, the 2 points come and become 1 point. At this point, we sometimes refer to that as double root or root of multiplicity 2 or identical roots and such. So that angle 0 is really the culmination of two angles that came very close to each other. One was, if you wish, 0 itself, and the other one is slightly short of 2 pi. They have merged into each other, and it looks like we have only one answer, but really there are two of them. They happen to be merged on top of each other. Same situation happens in all of these cases. Sine of theta equal to 1, there is only one answer, which is pi over 2. Let's go back up here and show you in this picture. When you want sine to be 1, well, here's 1. If you want to draw a horizontal line, it hits the graph right at the very top of it, and there's only one answer. The two have merged each other. Like there is pi over 2 slightly to the right, slightly to the left. Both of them produce the similar answers, and when you go to the very edge, they merge on top of each other. Same thing happens at -1. When sine of theta is -1, there is only one answer, which is 3 pi over 2. Or if you ask for cosine of theta equal to -1, that one also gives you only one answer. So at the four corners of the picture, okay, this picture has 4 corners. This situation happens that you have one answer. So theta equal to pi over 2, theta equal to 3 pi over 2, theta equal to 0 and theta equal to pi. These are the cases where you have one answer. In all the other cases, like the very first one, we had like two of them. So, okay, so what did we learn here? We learned that at this level, we are going back to our unit circle, search through the famous angles, and find out which one of them matches what we have. We should make sure we are not confused with x and y or sine and cosine. Just choose the proper one. And so this picture, we need to pay attention to it again. If that is the main tool we are using, so let me erase these things. Cosine matches with the x, sine matches with the y. X is the first one, and y is the second one, and that's what you use to get your answers. Okay, until next time, good luck and God bless.